upon reading the description of the block or the documentation for the block, you can figure out how the duty cycle is specified as a electric voltage. But since specifying the duty cycle as a signal is quite easier for me, I'll use that particular block choice. My duty cycle would be 0.5. Can be an arbitrary one. Even 0.1 would be fine as well. Oh, but I'll keep it 5. Right. It needs to be fed as a SimScape signal, since I can connect the Simulink signal directly. So I'll be needed to bring in a converter. So that should be it, but we are yet to parameterize 3 blocks, 3 SimScape blocks. Now let's move on to doing that. First, we have the stepper motor, and once again, you can go over to a datasheet for a particular motor of your choice, find out the resistances, these parameters, and some you may have to calculate as well. But there's another option that we can follow. So MathWorks holds a library of a small set of stepper motors. You can select some motor and update the block with that particular motor. So then the SimScape block will assume the name of that motor and will populate the dialog box of the characteristic parameters based on the datasheet that it has stored. So that's a quick shortcut I followed. And let's move on to the stepper driver. Now we need to specify threshold voltages for 3 things: enable a reverse, thresholds for 2, and an output voltage amplitude. And there are some choices for stepping mode as well. Now in a physical stepper motor driver, you will be able to select to, I think, around 8 or so stepping modes. Of course, full stepping is available, and then you have not directly, like you have half stepping, quarter stepping, so on and so forth. This will actually vary the parameters of how many steps are required for a full revolution. Just as a fact that you should know, in most cases for full stepping, the stepper motor driver will output 200 steps per revolution. Right, so we'll keep it at full stepping, no need to bother yourself with that, and we'll move on to specifying the thresholds for enable and the reverse. Now if we follow the convention that all logic will be in 5 volts, then if the threshold voltage for a logic value is kept at 2.5, anything below 2.5 will be logic low, anything between 2.5 and 5 would be logic high. So let's stick with the convention of keeping everything, all logic voltages of high at 5 volts, and then that based on that convention, the threshold voltages for logic values would be the half of that, i.e. 2.5 volts. So that's based on the convention. I suggest that you stick to this convention at least until you master SimScape to a comfortable level. And output voltage amplitude is quite important. So the stepper motor driver will power the windings of the stepper motor based on what we specify here. And in the real world, you specify this by whatever the supply voltage that you provide the stepper motor driver. If you power the stepper motor driver using, it can be powered using up to 48 volts or so, in some cases 60 volts as well. So based on what you supply, that would be the output voltage amplitude. I'll keep it at 12 for now. for no particular reason other than the fact that we have been dealing with 12 volts so far. So that should be it for the stepper motor driver parameterization. And now we'll move on to the control PWM. So the first one is kind of tricky, the required PWM frequency. It requires some calculation based on the requirement that we are looking for. Uh, that calculation was not seen in the previous case where was a permanent magnet DC motor. So I'll get back to it towards the end. And with regards to the other characteristics that we have to specify, we'll keep the pulse delay and pulse width at 0. And for minimum pulse width, I suggest that you keep it at an extremely small non-zero value. Right, and you won't be needing this if you are using the block choice of providing the duty cycle through a simscape signal. Output voltage is in fact important uh, since output voltage would be kind of the digital signal that it will be providing to the stepper motor driver. So the stepper motor driver will be taking in the pulse pattern as a digital signal. So it will be receiving the digital signal in logic high and logic lows. And our convention is to keep logic highs at 5 volts. So if the control PWM voltage block is to provide logic highs, and that voltage of the logic high should be 5 based on our convention, and a convention that advise you to stick with. And it's also what you'd observe if you were to provide the control PWM voltage signal to the stepper motor driver using a Arduino microcontroller, let's say the Nano or the Uno. Right, so that's it. No need to worry about input scaling as long as you use the block choice of provided duty cycle through a simscape signal. So that's it with regards to parameterization. I have to connect the solver configurator block first. I'll be keeping the solver settings to auto, and let's link determine what's best. I'm not going to touch anything on the right hand side of the motor, and upon clicking run, I'm running into multiple errors. I'll debug them and get back.